what we're doing here is applying technology to deal with the scale problem. Humans do well, but when tasks become repetitive, mistakes get made, things get dropped.
This is DevOps Paradox, episode number 180. What is AIOps? Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farson. A long time ago, we talked about AIOps. A long time ago, like almost 100 weeks ago.
That's too long for me to even remember. But I trust you. I believe
more than 2 weeks. Well, yeah, but any time more than 2 weeks for you, you're not going to remember anything.
Like a fish.
Or is it 2 hours? 2 seconds? No.
A bit long.
So today we have on with us Richard Whitehead from Moogsoft. Richard, how you doing?
I'm doing great. Thank you very much.
So Moogsoft is into AIOps. And we figured since we haven't really talked about it in a couple of years, let's define or redefine what AIOps is in 2022. So Richard, what do you think?
Well, there are plenty of definitions from analysts, which go into tremendous detail. I like to really simplify it and say that AIOps is the application of AI technologies, of which there's a plethora, an application of those technologies to the science and art of operations. So really nothing more fancy than that. It's reinvigorating existing tools and workflows with modern technology.
So let me think of an example. I'm just trying to wrap my head around it. Let's say that I have an application that I configured to increase the number of replicas for every 1,000 concurrent requests, right? That's something that I would do myself, manual, right? I mean, manual. The jump of the number of replicas is automatic, right? But I make those decisions. Now, would they be correct if I understand that actually, if that would be managed by some sort of AI, then I wouldn't be saying scale when there is 1,000 concurrent requests, but kind of the system would figure out that what's the best time to scale. Am I even close?
I think that's actually a good way of looking at it. And the key word that you use there is automation. So when you talk about artificial intelligence, the definition of artificial intelligence that gets all the press and all the Hollywood airtime is in terms of using computers to replicate humans. When it comes to something like operations, it comes to the technology world and what we do, it's less about replicating humans and more about simply automating things that humans would do but would rather not. So automation is a good example. So if you want to think of old operations being a mechanical machine that augments a human, AIOps, is basically bringing the computer sort of universe into it, allowing software to augment the human. So now we're dealing with more sophisticated reasoning and faster reasoning, as opposed to a mere mechanical advantage. But automation for me is the key.
So it's kind of more about automation than, let's say, decision-making, right? We're not there yet, kind of like. It's not deciding when it should scale, but it is automating that scaling that I mentioned in an example, right?
Yeah. I mean, an example of sort of the old way of doing things would be to create a metric, some form of indicator that determines when you should scale, and having an automation action occurs that says when this metric is exceeded, this threshold is exceeded, then we scale. In reality, it's a little bit more sophisticated than that. A human would probably make a decision. They would say, well, is this going to be a sustained increase in workload, or is it just a spike? What does it look like to me? Do I need to waste all the resources scaling when it's something that's clearly something that's going to throttle back? So that's a sort of a human element of the decision. Essentially, you're making the algorithm a little bit more sophisticated. That's really what I think it boils down to. Again, still augmenting a human decision in many cases, but a much more sophisticated decision.
You were mentioning at the beginning there about a plethora of AI technologies. In 2022, we hear about all the NFTs and everything else, and people throw AI at that. And that's not really what you're using, or is part of the underlying of all that what you are using.
So when it comes to AI, people tend to think of AI as a big data solution, where you take a vast amount of data and process it at speeds that humans would struggle to do so, and make intelligent decisions based on that data, either by categorization and sometimes even prediction, predictive analysis, trying to determine what might happen in the future based on that data. Or another example would be the use of AI in, say, a service desk example, where AI replicates a human in terms of asking questions. We've all had that sort of robotic experience. For me, it's more focused than that. It could be something as simple as applying natural language technology to a specific problem. Not even a big data problem, but just a specific problem. Or a particular algorithm or a particular finely tuned neural network aimed at solving one very specific problem. So there are lots of different technology. I mean, I've mentioned NLP and also neural networks, but also when you're talking about clustering, there are various clustering algorithms available, like k-means. So these are all very specific components that when grouped together, we tend to refer to as artificial intelligence.
That makes a lot of sense, because I misunderstood it before, that actually it is closely related with massive quantities of data. And then I was always wondering, hey, there is a software solution that has AI there somewhere in the title, and you give it to me kind of like, where is the data that you would kind of be trained on, right? But if data is out of the picture, then I can see it more clearly as potential, I give it to you as a software, and then that software does something.
Right, absolutely. We have a mind shaped by media, and media particularly loves it when AI goes wrong. That's much more newsworthy when AI works, which of course you never hear about. So we typically hear about these stories of AI decision-making mechanisms that went wrong, included bias. Particularly in the medical field, you hear a lot of stories of failed attempts at converting data into sort of reality. And that's a challenge, because data cleanliness is essential for AI to work properly. And by AI, I'm referring to things like machine learning, where raw data has been input. And I think when people tend to think about AI, they also think about prediction. That's the use case that I think has been oversold most significantly. Prediction is one of those things that it's at the best, it's really just sort of linear regression. You're looking back at historical data and trying to infer a pattern. And when you're dealing with capacity planning, that's a pretty good use case. I think that's been well established for quite some time. AI has really just improved the quality of that. But at the end of the day, there's that warning that they give you when you're stock trading, which is past performance is no indication of future performance. Certainly in the operational world where we live, a lot of that is very true. We're dealing with environments where things can't be predicted very well. So you need to use learning models with tremendous caution. An example would be, if you have too little data, you don't have an accurate model. But if you have enough data, then it's probably out of date. So in rapidly changing environments, which we're beginning to see increasingly in software and application delivery, the amount of data that you have at your disposal, it becomes a challenge because of the rate of change that we're seeing.
If I now exclude AI for a second, and machine learning and what's not from conversation, isn't most of what we do as ops, sysadmins, whatever we call ourselves these days, based actually on mental prediction model, right? I create a cluster that is regional instead of zonal because my line of thought is predicting that actually if one zone fails, that will be a bad thing. I need to be regional, right? Kind of, aren't human actions mostly driven by subconscious, if not conscious, predictions of outcomes of stuff, right?
Right. And that's another great example. I certainly think an area that I'm interested in, certainly keeping a close eye on, is the use of AI techniques to predict the impact of change. So when you're building environments, having AI analyze your projected configuration and determine, come up with some suggestions about, well, we have potential single points of failure here and things like that. That's definitely an area of growth that's anticipated over the next couple of years as people start applying these models to that. And I think that's a very worthwhile example because, again, what we're doing here is applying technology to deal with the scale problem. Humans do well, but when tasks become repetitive, mistakes get made, things get dropped. So it's much easier just to entrust this in sort of software. I think it's sort of analogous with doing sort of vulnerability and sort of code scans on software. You could have a human sit down and read all the various vulnerability reports and make sure all the versions of your Docker images are up to date and so forth. But it's much nicer to know that that's happening automatically as part of your CI/CD toolchain.
From that perspective, would be far-fetched if I say that we had AI for decades, in a way, kind of because we have CI/CD pipelines, automation, what's not, since the dawn of time, in a way.
Yes, absolutely. AI has been around for a very long time. The example I used earlier in terms of service desks, I think, that's almost 30 years old now. I made a reference to a specific algorithm, k-means, that's almost 60 years old now. So AI, in terms of the underlying technologies, it's been around for a very long time. From our standpoint, AIOps is something that's fairly new. That's a term that's been coined in the last sort of 6 or 7 years to describe the application of technologies that are in some case quite well established to the role of operations. That's been a little bit trickier. I've been essentially evangelizing AIOps technology for just over 8 years now. And when I first started, I was met with a lot of skepticism. There are a lot of people who were reluctant to move away from their very deterministic, very well-structured IT environments where absolutely everything was highly predictable. And they were very, very skeptical about the application of anything that could be remotely described as fuzzy logic or anything like that. They wanted predictability. They liked hard-coded. But the reality is that doesn't scale. The rate of change that has occurred in the last 8 years has changed that conversation from skepticism to, okay, we know we need it. How do we make it work?
So how little is too little data? Let me rephrase it just a little bit. If my churn rate of whatever it is that I'm doing is so low that it's not statistically significant, therefore no predictive model can be built off of it, I don't really have a use for those kinds of ops, right? That would be a mismatch at that point.
Yeah, in terms of prediction, the volume of data is very important. When you're dealing with large environments, if you're dealing with potentially thousands of servers, the size of the data is very, very useful because you really need to understand how a particular piece of hardware will work. And the size of data is your friend there. But if you were to look at some other use cases, an example I like to use, because as a non-data scientist, as a mere engineer, I like to get my head around things in terms of practicality and practical sort of outcomes. An example would be the correlation of a tag. So let's say you have an environment where you have some application labels and you want to group them together, but maybe people spell things differently. Maybe the full word isn't used in its full context. Maybe there's this, uppercase and lowercase isn't used consistently, and underscores are used in places of spaces and things like that. applying things like natural language processing to that problem, first of all, it saves you having to write incredibly horrible regex expressions to incorporate every conceivable way of spelling something like, an example I use is checkout. First of all, it saves you that effort, but also having created a hard code rule for checkout, what happens if somebody introduces a new service and it's one's called processing? Well, now checkout is not the same as processing. Your regex has to change. Whereas natural language processing doesn't care that the word has changed. It just needs to know that processing is one word and checkout is another, and they both have stem words, check and process. What that does is, not only does it reduce the amount of regex you're writing, which is laborious. As someone who's been writing regex for almost 40 years, I consider myself a newbie, just getting used to it. So you've saved yourself the effort of writing the regex, but you've also created something that will scale in terms of the number of names and labels you're introducing. You don't have to worry about, if I introduce a new label, like I've done checkout and I've got processing, maybe I've got payment. Well, now you don't have to worry about introducing the word payment, because the clustering algorithm that's working on those terms will acknowledge that payment is a new word and it will start clustering around the word payment. So it's very scalable and very robust. And as you can see, we've, in that entire discussion, we've only introduced 3 different data sets: checkout, payment, and processing. So very valuable, very tremendous benefit for the individual, the person constructing the system. But we didn't need a vast amount of data to make it worthwhile.
I also want to go back to data cleanliness. How do you determine if data is clean?
Well, and that's another sub-niche of the AI market, is trying to determine how do you get clean data. So one of the techniques is to create the data yourself. So you create essentially, sterile data because you created it, so it does not contain any anomalies. Or you create a sample of data from your environment and a human makes the determination. This is what our environment looks when everything's working okay. And that data is now determined to be okay. That gets a little trickier when you're dealing in real time, because in real time, you have no historical model. You're just looking at the data as it currently is and trying to determine whether something is good or bad. The 2 ways that I've sort of found very effective for dealing with that environment is you can train the system. So you can give it some sort of reinforcement where it thinks it's discovered an anomaly, and you as the human can go in there and go, no, this is to be expected every week. You just haven't seen it before because we've only been running for 4 days. Another example is just to let the system go on and eventually learn that this is not anomalous behavior. This is without any input from an individual, I'm going to just assume that this is normal. I've seen some good examples of that, where you can, an example I use a lot is CPU utilization on a Kubernetes node after a code deployment. The CPU goes from its normal sort of 40% utilization and suddenly goes up to 70% utilization. Well, that creates an anomaly, and in theory, that could be a serious issue, but not if the intention was to use the CPUs more efficiently. So if you wanted, the goal was to basically not leave sort of resources on the table and to make more efficient use of the node, then you just say, nope, we're just going to mute that alert. That's not a problem, and allow the algorithm to learn that now 70% is your new normal.
So let me clarify that. So normally it was 40, it went to 70. Now we're getting alerts because we're above 40, and I'm just going in and saying, ignore, 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 until finally it slows down to be ignore, ignore, until finally it becomes not even there anymore.
Well, hopefully your environment is set up that you only get one notification of the threshold violation, and you only have one to mute and not repeated ones. But yes, the idea is that in that scenario, a human presented with that data without having done anything up front, a human with that presented with that information will basically say, okay, that's working as intended. 70% is our goal. We'll let the system learn that. So we're going to, and the alternative is like, oh, wow, 40 to 70. What's going on there? We've introduced something that's not right, in which case you would probably back out the change and do some investigation. The former use case is is pushing the envelope. That's not traditional ops. Traditional ops would be trying to be a little bit more proactive. In that environment, you would probably set a maintenance window. If you knew that the goal was to increase CPU utilization, you would say, okay, for however long the learning periods, let's put that system into a maintenance mode so we don't get paged at 3 a.m. for CPU spikes at 60%.
That was going to be my follow-on question is how long should that training session run? I mean, basically what you said is in the old way, you would go into a maintenance window. But it sounds like to me, I would still go ahead and put a maintenance window in so I can silence any alarms, but the training is still happening all the time under the hood.
Right?
Okay.
So training, there's no real magic there. At the end of the day, you do have to have an understanding of what your data is going to look like. So, if you're dealing with and the rate of data as well. If you're dealing with information that's coming at a very high velocity, you might want to set a very large number of samples. So, a small spike doesn't skew your threshold significantly. So that should, generally speaking, be an adjustable parameter set up by somebody who has a reasonable understanding of how the environment works. That's probably the best way. Now, obviously, the state of the art is changing, and the goal, everybody's expectations is, well, wouldn't it be nice if you could learn what kind of data we're dealing with? There are some sophisticated techniques out there that really help in this space. So if you have data that doesn't conveniently flatline, so if you've got a CPU utilization that remains steady at 60% all day long, when it doesn't do that, I've personally seen entire fleets of EC2 systems in a customer's elastic compute environment exhibit this beautiful, almost sinusoidal diurnal pattern, peaking at midday and dropping off at midnight with a lovely sine wave in between. So that's a little bit more difficult. You have to take that into consideration and say, we need at least a day's worth of data before we can make a decision. And of course, in this particular instance, because it's based on, the load was based on customer activity, we also found that there was weekly periodicity in there as well. So Saturdays and Sundays dropped off as well. So now you need a week's worth of data to make a meaningful decision.
But then how do you know that you need a week versus a day versus a month?
Well, only time will tell.
Where should you start, though? Should you just start at a day and see for a few days, see how it worked? If that didn't work out, bump it to a week or something? It just as gross chunks of time?
So personal experience has told me that starting off with the assumption that you're going to have those kind of patterns, if you understand the application and the way it's going to be used, you could probably start with a strategic planning assumption that we're going to have diurnal data. But we don't, maybe Mondays will be different to Fridays. We don't know until you get the data in. But you at least now you've got a starting point. The exact example I used there, I found that when collecting data samples, 1 week's worth of data, because there was this weekly pattern, 1 week's worth of data was useful, but it was flawed. There was still a strong likelihood of false positives based on the fact that 4 minutes past 11 this week was not exactly the same as 4 minutes past 11 last week. So you need more data samples. What was interesting is I found that 2 weeks of data considerably improved the results. 3 weeks of data improved it, but not the same level of improvement that you got after the first week. So that's your trade-off between modeling based on observed data and predicting and creating your own model, where you say, okay, I have a day's worth of data. What I'm going to do is set my thresholds based on this manually, not using observed and calculated standard deviation. I'm going to manually set that threshold for any given time of the day. And I'm going to lower it by 20% for the weekend just to see how it goes. So that's the trade-off between, sort of starting with a working example and then as opposed to observed data.
But isn't that the difference also between humans and machines in terms that we have physical limitations? Like I cannot be dedicated 24/7 to watching stuff and making decisions every minute. Therefore, I need to make a decision after a day, after a week, or whenever, and stick to it for a while at least, right? Because I'm off to something else. But machines don't have that limitation, right? Kind of, why would a machine be limited on making a decision once or based on one day or 1 week or 1 month? Kind of like, why not just make decisions constantly? Why would that be a one-time decision?
So again, based on the context of the data you have, machines are extremely diligent. The quality and consistency of their work is absolutely fantastic. What they're terrible at is things like intuition and predicting things that have never happened before, or at least allowing for things that never happened before. So that's what your trade-off and your balance between what gets fully automated and where you need the human to both coach and guide it. So I mentioned that there are multiple techniques. Real-time unsupervised machine learning is where there's no learning, there's no training involved. You just build a basic model and then let the system adapt to the data as it's coming in. That's great, especially for real-time processing and for data that you can't necessarily predict up front. But as you get more information, you can then start moving into sort of semi-supervised techniques where maybe it started off that way, but now you have an individual going in and reinforcing it. So maybe training a neural network to say, that was a good attempt at determining whether that was a problem, but in fact, it was incorrect. And from our standpoint, that's a really good technique for things like probable root cause, where you're trying to determine a root cause from a symptom. The machines will do a really good job of determining correlation, but as we know, correlation doesn't always mean causality. So humans coming back in and going, okay, we've had our retrospective. We know what the root cause was. We're going to tag all of these as symptomatic and this one as a root cause. And maybe the system, the next time it sees that, it will say, okay, the last time I saw this particular sequence of events, this was the root cause. What do you think? And I think the goal in those kind of systems is initially, depending on the severity of the outcome, you wouldn't want to automatically attempt to resolve the issue. You have the human in the middle type AI approach, where the system offers an intelligent suggestion where it says, I've just seen a sequence of events, and in 65% of the times that I've seen this, you've indicated this is the root cause and this is the correct way to resolve it. Do you want me to do that? 65% of the time, this was resolved by an auto scale, or 75% of the time, you had to do a code revert. Would you like me to do that? And then again, over time, as confidence builds, the system can, if you get to like near 100%, then why not let the system do it automatically? Personally, at this stage in 2022, I don't see 100%. I feel that if you see 100%, you've either spent far too much on your infrastructure or you haven't changed it very recently. These are two things we don't see in this time. What we see is a balance between cost and effectiveness and an attempt to change things very dramatically. The constant rate of change is sort of the biggest enemy of anything that's fully automated, particularly if there's any kind of hard-coded rules involved, because we're constantly changing things. I seem to recall a statement that was probably true about 20 years ago, where Gartner said that something on the lines of 75% of all outages were caused by changes. That number's creeping up because we're making more changes. But it's also harder to predict because the infrastructure is not static anymore. Multiple code pushes a day. Nothing's the same as it was 10 minutes ago, let alone 2 weeks ago. So that's why I think that the human in the middle is going to be an important part, and solutions and technologies that apply AI need to accommodate that. It's all about the speed of feedback. You can't necessarily predict a change is going to break something, but if it does, you want to put that information in the hand of the individual as quickly as possible. But it's a constant and very rapid feedback, collaboration, making sure that not just operators, but the developers responsible for code changes are alerted immediately that a problem happens. Maybe even before a root cause has been determined, just so everybody's ready. That's one of the DevOps principles that I think in my world of real-time operations, it's the feedback part of it, and the continuous sort of experimentation, constant changes, constant feedback, and the more flexible your AI can be, the better. We're seeing some really interesting techniques in terms of making accurate predictions based on highly unpredictable data. If you have a nice straight line, everybody can extrapolate that and figure out where it's going. When things are going up and down in very strange patterns, then that becomes a lot harder. But we're seeing some really interesting advances in things like short-term memory models, where those kind of patterns can be identified.
Do you ever see data sets moving from just X and Y into X, Y, and Z?
Yes.
What does something like that look like?
I don't know if it's necessarily the right answer, but what immediately popped into my mind was graph theory. So, it's more than just sort of X and Y. You've got additional relationships as well. Typically, it's very basic. Graph theory, you have 2 nodes of a path. So that's three data elements right there. So that's another area of interest. When we look at basic clustering, correlation type clustering models, where you're looking to infer relationships, the techniques that I'm most familiar with are time, features, and topology. Time is obviously, at its very basic, things that happen at the same time might be related. The example I use with NLP, that's a good example of feature. So if you're looking at strings, like maybe tags or labels that contain similar phrases or words, or you're leveraging naming conventions or even addresses, physical locations, those are examples of things where correlations can be inferred from, that's happening in the same place. Or we're seeing a bunch of messages from different parts of our infrastructure, but they all contain the word payroll. And then the topology is the other one, where you have a dependency graph, where that certain things are related to each other. That a service is dependent on communicating with the bus and accessing a database. So now you have a dependency graph there. So that's another example of beyond just time series.
Now let me ask a really interesting, to me, business question. Do you use Moogsoft to monitor Moogsoft?
Yes, we do. We call it drinking our own champagne. So yes, we do. It's not the only thing we use to monitor.
Well, that was going to be my next question is, okay, so if you're dog fooding it or drinking the champagne, whichever way you prefer to reference it, what has been one of the learnings of monitoring yourself with yourself that you went, we would have never guessed that, and it was bubbled up through your training models?
There weren't that many surprises. And I think that's because we're obviously subject matter experts on our own product. For me, one of the big lessons it taught us was the importance of good quality APIs. If you're monitoring something, then you need to be able to access the data. Being able to access information, the right kind of information, the right indicators, and just simply be able to gain access to the data is very, very important. There are a couple of instances where we found it was difficult getting important data out of our own application. Back in those days, of course, the product was designed to monitor other people's applications. It was not designed to be monitored. So I think once we started using our own technology to monitor our own technology, that really changed the game in terms of improving APIs. Now I'm glad to say our product is extremely observable, simply because we didn't want to have that difficulty.
Because you were already feeling the pain. It's like, this is silly. We can fix this.
And it's also a little bit embarrassing. You know, it's like you can't claim the moral high ground when you're criticizing another vendor's API when it would be similarly difficult to get the same data out of your own. So, yeah, that was an important lesson, is the making sure that, doesn't matter what your software is doing, it needs to be observable.
So let's go ahead and talk about Moogsoft. Again, basically AIOps, but does it mean SaaS? Does it mean self-managed? What does it mean?
We're a company that sort of started in one world and migrated to the other. So initially, this kind of technology was really something that would be deployed as a major corporate sort of IT, centralized IT type project. So it would be built within a data center on vast numbers of servers, fueling all the all the algorithms and all the processing and dealing with vast amounts of telemetry. But we've seen a shift. We've seen a significant shift from customers saying, well, I really don't want to maintain this in-house. We're trying to remove anything from our data center that isn't our core business. And sort of things like monitoring and ITSM and service management, those are generally not considered core business. So as a result, we found that a significant percentage of new customers were requesting a SaaS solution. Now, there are still some who are struggling due to either extremely high volumes of raw data or through some kind of real or perceived governance issue in terms of where data should live and how data moves around the public cloud. But yes, the technology now is a cloud-native SaaS solution. That's very easy to engage with, and it's opened the door to some more sort of departmental type engagements. This doesn't have to be a major corporate initiative signed off by a CXO anymore. If you want to start playing with some of the technology, that's something that can be done, at a very small team level.
When you were mentioning there the volumes of raw data being so large, what scale are we talking about? Are we talking starting at petabytes and going up from there, or is it smaller than that?
So when we sort of measure volume, we generally we're talking to rate. Rather than absolute size. Size is obviously an important dimension, but rate is the most significant one. And when you look at some very large enterprises, and in particular telecommunications organizations, the sheer scale and volume of the data, because of the physical size of their infrastructure, telecom switches and these things, they generate an enormous amount of telemetry. And you're dealing with, many millions of events per day with tremendous scale. That's something that you have to take into consideration. You can't just say, okay, that's no longer going to go on our own private backbone in our data center, on our own fiber network. Now we're going to stick that up over the internet, into Amazon or somewhere, AWS. So considering, you have to look at it and think, okay, do I really need all that data? Can I do some processing locally? So it becomes a different architectural decision when you start moving to a SaaS type solution.
Correct me if I'm wrong, but basically you've got the fire hoses inside your whatever your four walls are, but your egress is a little straw, and that's not going to help you any. So having something as local as possible and then shipping what's left over to the straw is an okay, but it's a much harder implementation detail than just saying, here's my nice fat fire hoses everywhere.
Yeah, absolutely. Some of our customers are very lucky. They've grown in the cloud. They were born in the cloud. They've grown in the cloud. This is not an issue. This is, everything's being designed and scaled for that type of environment. But, there are some particularly legacy. I mean, we have customers who their telemetry data has been transmitted over a protocol that just can't go over the internet. So, that requires a different, there's going to be some kind of local processing that happens. You can't just send it to an endpoint at some URL. I'm looking at you, SNMP.
That's being polite. Being very polite. Well, all of Richard's contact information is going to be down in the show notes. But Richard, if people wanted to not look in the show notes and figure out where to go, what's the best thing to do if they wanted to try out Moogsoft?
Moogsoft.com. That's the best place to start. If you want to tinker and experiment, as I do, I have my Raspberry Pi in my basement instrumented and send it up to my own instance. And I like to experiment. I particularly like to experiment with the NLP. That's been a lot of fun. I connected the product to a Twitter feed and started doing correlation based on hashtags. So have a lot of fun there. You could sign up for a trial, maybe apply for the free tier.
So are you telling me I could train the model to auto-scale my Kubernetes cluster by using Twitter hashtags?
I would not recommend it. It was an interesting experiment that I did, where I was looking for outages, and that was the successful word, outage. I was able to basically look at Twitter feeds, look for the word outage, and then cluster based around the ID and the mention. That was fascinating because that basically meant that I was getting notifications of any outage that was occurring. And I found that there are certain organizations that had real issues with outages, power companies, cable companies. But what was nice about the NLP is I was learning about companies I didn't know who existed. Regional ISPs in New York State that I had no idea about, power companies in Southern Africa. That was a good example. I also realized that the hashtag network was a very bad word to use, because 99% of your tweets would be related to Hollywood and TV and basically network broadcasts. So not what I was thinking. I was thinking of computer networks, but
yeah, no. They stole that from us.
They did.
Oh, well. Richard, thanks for being with us today.
It's a pleasure. Thank you for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.